All right. Hey, look here. We are here. This is James and I. James, you're small again, but I got you fixed. There we go. All righty. Yes, we are here. Let's make sure we got sound. James, talk to us again. Nope, you're muted. Hang on a sec. There we go. James, talk to us again.
Hi, how you
We
doing?
fixed it! Yay! There we are.
How's it
Sessions with
all?
Sam. All right, can you all hear us? Rob, give us a hello if you can hear us. My man Rob Sutter, as always, is moderating. He's awesome. He no, he just sounds muted in real life. Okay, that's fair. Rob, I need a hello if you can hear us. Can you tell us whether you can hear James or not? We're waiting. We're waiting.
Hello, hello.
Yeah, I'm just gonna check myself. Oh,
I'm still here.
no, it seems like
Yes. Okay,
okay,
great.
yes, we are good. All right. Well, welcome to Sessions with Sam. Rob's yelling at us now. Did you see that? He's yelling at us. Hey, you know what's in here? Of course you do. We got Diet Dr. Pepper in here. Serverless for everyone. Rob is still yelling at me. Rob, stop yelling. Okay. And this is my man, James Beswick. Bezick. Dadgummit. That's going to be in the recording. James Bezick.
Everybody gets it
That's
wrong.
how you, yeah, but I've known you for how many years now? I should probably get it right eventually. Yeah. So my name is Eric Johansson. So that's also often gotten wrong. And we are here to talk about SAM, and we're going to talk about EFS. James, give them a little of who you are and what is EFS?
Yeah. So I'm also a developer advocate. So both Eric and I, our job is to help people understand the benefits of using serverless to solve their problems in their businesses and organizations. So EFS is a very new feature in Lambda. It's pretty exciting actually. So before EFS came along, if you wanted to work with files, you generally had to pull them from S3 or some
That's
other
right.
location, and then pull them into the temp space in Lambda. And you only have 512 megabytes of temp space available. So you had to get fairly creative about how you use that if you've got very, very large files. EFS actually gives you this ability to have essentially a virtually limitless file system available, and it's mounted into your Lambda function like you would any sort of directory or drive in a Linux system. So it means you can put really, really large files or lots of files and make those available to your Lambda functions.
All right. So tell me this: is there a limit?
Not really. I mean,
Okay.
at some point in the cloud there is a limit, but the chances of any of us reaching it are not that high.
Gigaflop of Hootabytes. I made that one up, but yeah, petabytes, right? And it
Yeah,
grows, and then as you get rid of stuff, it also shrinks. So it's
right.
elastic. That's right. So which is why they call it elastic, and I know that. So all right.
Yeah.
So here today we're here to talk about how do you manage. We created support for EFS with serverless with Lambda functions. That was for you, Chris Munns, and apparently I rarely say it right, so I work with lambdas all the time, and I just said lambdas. There it is right there. But and so we've just added support. We also added support in SAM. So today James is going to be walking through. James Bezick, the one and only, is going to be walking us through how do you set this up. Now tell us some of the not caveats, but some of the things, like for instance VPC. Does it have to run in a VPC?
Yes. So there's a couple of things you have to know, and once you know them, it's easy, but it's important you understand how they work. So some resources in AWS, you have to use a VPC if you're connecting with Lambda. And so EFS is one of those. You have to make sure the Lambda function is running inside of a VPC. And the second part is really configuring that Lambda function so it can connect and mount to your EFS file system. And once you've figured out those two things, it's really pretty straightforward. You access the files like you would any other file available within the function.
Right, exactly. So obviously they're locked around there. So, sorry, was answering some questions as well, so we can
Yep.
take care of all of this. So, okay, well, so I'm going to turn the screen over to you, and will you show us kind of now? We're not going to build this all out because there's actually kind of a lot to do on this, aren't there? So James is going to walk through this, and afterwards we're going to push these templates up, of course, to the repo, so you have access to it. And with James, with that, you're on, man.
Oh, great. So basically, I set up a repo with 5 different examples, and I've cloned them to my Cloud9 instance here. So we've got them numbered 1 through 5, and if you download this later, all the instructions are available in this README MD file, so you can go through it at your own speed. But there's a couple of interesting ones I think are worth calling out. And so the first one in setup is actually not SAM, it's actually CloudFormation. So I'll show you little bit about this. And here you'll see there's a template that sets up a VPC and subnets and all the various things you would need for this to work.
So you just brought non-SAM templates into my SAM show. Is that what just happened?
I'm afraid so. Yeah,
Okay.
that's it. I brought CloudFormation in here.
Hey, just to give everybody
And
a heads up, you're going to see James's face resized multiple times. I'm not sure what OBS is doing to me today, but just periodically it just makes James bigger or smaller. So I'll work with it. We'll have fun. James, back to you and your cloud
sure.
formation.
So this is totally optional in terms of setting up a brand new VPC, but if you want to, this is a useful template to have available and has all the information you need to actually set up this file system directly in CloudFormation. So this you can set up in the console. So if you go to the regular console, it's all the things that you would see inside the EFS section here. And so when you create a new file system, it's all of these steps essentially, but it's easier to write it as CloudFormation, at least I think so anyway. So once you have this set up and you run this, and you just run this with a CloudFormation script, not a SAM script, that's how you create your EFS file system. And I've already got one earlier in the true style of television. We've got an EFS mount here available for us to use.
So let me ask you a question. We actually had a question come in here. So is there a performance penalty? When is the EFS mounted? Is it at mounted creation? Is it mounted at invocation? How does that affect your Lambda start time?
It doesn't impact cold starts. So essentially the mount happens at the same time as when the execution environment is being constructed, but it happens in parallel. So in all the testing we've seen, I think Lumigo did some interesting benchmarking on this with the Ankui stuff. It's not actually going to impact your cold start time.
There you go.
So once you've got, so this I just throw in here because I think it's useful to know how your VPCs are created, but everything I'm going to do is running inside my default VPC and the things I've already. What I wanted to share with everybody was a few really useful commands that I figured out, because you really want to be able to find your VPC IDs and subnets and access points, and once you've got those, it makes it much easier to work with SAM. So the first one is, how do you find your VPC? Well, you can use this command AWS EC2 describe VPCs, and when you run this, I'll make this a bit bigger, it gives you a list of all your VPCs. Now I can tell I've only got one here because it's the default one, and that is where you find your VPC ID. So I'll copy that and use that for later. The second question I ran into was, how do you find the list of your subnet IDs? Because this, again, if you've got lots of VPCs, you can end up with lots of different subnets. So what we can do here is use another command, another CLI command, for describing your subnets, but filtering where your VPC ID equals that value that we just pulled out from the first command.
Okay.
That gives you that block of JSON.
All right, so let me ask you a question. I run serverless, right? What do I care about subnet zones or availability zones?
Yeah, so you want to think about the fact that Lambda is a multi-AZ service. So under the covers, it's running in multiple availability zones for you. You don't ever have to think about this normally.
Yeah, it is.
And we always think about things in terms of high availability. So when you create your EFS file system and your access points, you also have a way to select availability zones there too. Okay. So you want to make sure that you've got the same list of availability zones when you create your EFS setup as when you create your VPC configuration in Lambda, because if you have different sets of availability zones, you'll find situations where Lambda runs in an availability zone where your EFS is not set up and it won't work correctly. So you want to make sure these two lists are the same.
Okay, so the VPC availability zones and my EFS availability zones need to match.
Yeah.
All right, and these commands that you have, we can make these available in the repo when we push it up, right?
Absolutely.
These helpful commands. Excellent. Thank you.
Yeah. So I don't need to write these down at the moment. I just wanted to show people what they do. And so this obviously is JSON. It's not that helpful because we just want a list of the subnets. So what you can do is add a query filter onto this command. And then using this syntax, it just gives you a list of your subnets, and this is great because you can copy and paste these directly into your SAM template, which I'll show you in a little bit, but this command is really helpful. And then finally, in the list of commands worth knowing is getting your EFS access point. So again, this is just one simple CLI command, AWS EFS describe access points. And what you're looking for here is this ARN. So that's one you want to copy down and keep safe once you've got your EFS system configured.
Okay, so let me ask you a question. Now, we're showing these separately. I could, if I had these in the same template, let's say I'm building my access point in the same template, I could reference that through a SAM, like a ref, right? Exactly. Okay, excellent.
Yeah. So I'm just showing these just because I think it's useful to know the CLI works.
Yeah,
but if you combine these into your SAM template, that'd be super powerful. But what we're really here for is the SAM template. So I created, I think this might be the first Hello World SAM template
nice.
for EFS, I hope. But I was building this when we were testing out EFS. And what I came up with was this way of passing in as parameters these subnet IDs and the EFS mount point and your ARN and your security groups. By doing that, by putting these all at the top, we can then pass those in to the VPC configuration and the file system configs. And essentially, the rest of your template is more or less the same. It's just adding these extra parameters. So when you deploy your Lambda function, it automatically sets it up with the right VPC configuration and with EFS already set up. So what I really want to do is deploy this function just to show everybody how this works. I'll just make this a bit bigger.
And you're going to use, of course, SAM deploy.
I think I might.
I love it. Makes me excited. Do it. Rob says do it.
Using SAM deploy guided. So let's see how that works. So remember, I've got these parameters that is passing in. So I'm going to call this Hello World EFS. I'll run it in US East 1. I copied these down earlier, so I'm going to copy my security group ID, then my list of subnets that I extracted from that command, but with commas between them. Paste those in. I'm going to accept this default mount EFS, and then I'll put in this. What was our EFS? No, do we remember?
Should be up there. No, yeah. I memorized the ARN real quick when you copied that.
Yeah,
because I have that kind of memory power.
I'll paste those in. I don't want to confirm changes, and then let that just continue. Let's let that deploy now with those defaults.
So we have
and so this is just hello world.
So while that's deploying, we have a comment in here, and I like it. Doug Toppin says it can be useful to save default values such as VPC ID in the parameter store by name, and then have CloudFormation or SAM templates, which they are CloudFormation templates. They transform. Read from the parameter store by name. This would be for resources created by means other than CF, and you can create them via CloudFormation. It can store it to PS well. Yeah, that's a great call out. And anytime you can move that kind of outside, another way we could do this, we could actually have exports, stack exports, and then we could do stack imports, right? And that's one way. But those stacks sometimes that becomes pretty painful sometimes. And so I agree with you. I tend to push to the parameter store where we can. And SAM and CloudFormation in general work great with the parameter store and saying, hey, we want this type, and you can adjust by name, unencrypt it, so on and so forth. So yeah, great suggestion.
Yeah. I think, the key thing in getting to grips with this is really this fact you've got to set up your VPC with your Lambda function and also provide this access point for your EFS file system. Once you get that far, it's actually fairly straightforward to manipulate the files. They really operate in the same way as when you use a temp space. Temp space is obviously much faster because it's literally in the same space, but in terms of how you access them, it operates in a very similar way.
So let's talk real quick. Now, you've broken these into separate templates, and I really like that. Now, earlier I was saying if they were in the same template, you could do that, but that would be pretty nightmares to manage here. And I like your recommendation, and I approach this as well, is if I'm going to build something like a VPC that a lot of my different stacks might be using, or EFS, I don't know if you noticed, but dare I say it, containers, ECS and EKS now support EFS as well. It's a lot of acronyms there, and I'm stumbling over myself. And so let's say I have an application that's using multiple technologies. We're using serverless for 99.9% of what we're doing, but maybe we want to, throw something out to containers, or we have an EC2, a legacy system, whatever, and we still want to use EFS. And so by separating those out, then I can just refer to those and using Doug's advice of dropping them in the parameter store. So this is a great way to decouple. But it's like we talk about decoupling applications and code and things like that. And James can attest, we spend a lot of time talking about that. We also say, if you can decouple your stacks that way, it's a great approach.
Yeah. So that's our finished deployment. So if I take you to the Lambda console, you can just see what's happened. The code is nothing special.
I'm impressed that yours deployed first try. Mine always do sometimes, once in a while. So that was good.
So I'll open up this deployed function. Now the code is just literally hello world, but further down, this is the key part that's different. So if you scroll down to this VPC section, you'll see that it's now within my default VPC with that list of subnets that I specified, and along with the security group I put in. And then further down, you can see that that EFS file system we looked at earlier has been configured here, and it's available at the mount EFS mount path there. So that's your basic. That's your basic hello world example, and you can clone this repo and test this out and modify it for your own needs, but it contains all of these different SAM parameters that you know. I mean, it really is just about 6 to 10 different lines of code, but they are important for making it work.
Yeah. So think about, and I love this idea. Okay, there's a conversation on what is a container going on here. But a few lines of code, that's really kind of basic. This is a simple example. But this is a pretty significant feature that we're adding. And it kind of blows open the door for some different, what are some of the use cases you see jumping on this? And if I caught you blindsided, you can say, I don't want to, but that's all.
No, there's actually a lot of interesting use cases because you could previously use S3 and other stores to be able to do things, but
you had to load it.
And then with S3, you cannot update files without creating entirely new objects, and you get charged for puts and gets. So if you have a process that creates thousands of files, that may not be the best solution for you. And also for incredibly large files, manipulating them, there's elements of performance too. So this opens up all of those types of cases. And so in the repo, I put a couple of examples where one shows you a large file. So we took a very large MP4 video and then show what it would look like if you ran FFmpeg, which is a library that lets you process video. So it uses this large file to take 1 frame of video per second and save that back to EFS.
Wow.
And it's also great for zipping files if you've got thousands of other files, or for unzipping very large archives into place. So it's got lots of different use cases.
So there's one I'm going to point out. There was, and then we have a question. Someone pointed out that on line 47, you've got a typo. I'm not judging. I'm just saying that there's no such thing as OGs. So whatever you want to do there is fine. But
it's a good call out.
There you go. So here's a question. Is the VPC public? Meaning, if I use the default VPC, does it allow me to access a public URL? So there's kind of two parts to that question. So you're saying, does it allow you to access a public URL from inside your VPC? It depends on how you do your NAT. You can do a NAT gateway to do that kind of thing. So that's one way. So I'm calling out from my infrastructure inside of VPC, and I would need a NAT gateway. If what you actually mean is, are you being able to reach into, can something reach your stuff in the VPC? Again, and Rob is throwing out some answers, but yes, but there's some depends on how you're setting up your internet gateway, how you're setting up your boy, I do serverless so much the words are jumping out of my head, but how you set up the egress and ingress. And I really do find that because I do serverless so much, sometimes I forget. I used to be a solutions architect for a company where I did networking all the time, and it's like, so use security groups is the word I was trying to say. Thank you, Rob. Thank you for clarifying. Rob thinks he's so smart. He is actually pretty smart, which is really kind of irritating. So, okay. So, what other questions? And James, I'm gonna let you continue in a sec. But do we have any other questions? Go ahead, James. I'm sorry, we're trying to say something.
Well, let me show you something really interesting. So, obviously, EFS is really like a big hard disk, so you've got pretty much virtually limitless space you can use, but being able to browse the files is very useful. So there's a couple of different ways you can do this. So if I go back to my EFS console, and this is the EFS I set up earlier. In this section just here, you'll see a part that gives you mount instructions for EC2. So if we click this, it then gives you these instructions. So you can actually spin up an EC2 instance and mount it and browse this. But of course, we're serverless, so we don't want to use EC2.
Yeah, exactly.
And so we've got Cloud9 running. Well, Cloud9 under the covers does run EC2. So we can actually mount this to our Cloud9 instance. So you don't need to follow these installation instructions at the top because these tools are already installed on Cloud9. It's really just these two commands here. So I need to create a directory and then basically mount my EFS file system to that directory. So if I just go back to here, I've got this directory called EFS. So I'll just...
I'm not gonna lie, I'm pretty sure you just blew Rob's mind. So
if I just mount that, I'll put in, I want to mount to environment EFS. What we can do now, if I just cd into that, is you'll see I already have a couple of files in. Oh, there's a directory in there.
wow.
We're now browsing the file system directly. So it's that easy pulling it in. And then as you start to create files, you can put them there and it'll disappear in your EFS system automatically. So if I then take my example, I've got this third example, large files. I've got this file called video MP4 just in this directory. So I'll cd into that directory. And I want to move this. I want to move video MP4 into environment EFS. Oops, get my permissions right. And then inside EFS now, you'll see I've got video MP4. So moving files between your local file system and EFS or through Cloud9 is actually very simple. And then the critical thing is that video file I just put in EFS then becomes available to your Lambda function. Now, one of the subtleties here is that it's not just available to one instance of your Lambda function. So if you have a function that's processing, let's say, a very, very large file, and you want to parallelize the workload, and it scales up. As it scales up and they're all connected to the same EFS mount, all of those instances of your Lambda functions are connected to the same EFS locations. That opens up all sorts of possibilities for the way that you can process files.
So I have a question here, and I'm gonna answer this real quick here. So Nacho Pants, you're asking, you have 100 plus staff struggling with mounting drives from the desktop. I'll tell you what we do. Yeah, and I've seen folks doing stuff like that. It's a little out of scope for what we're talking about at the moment, but if you'll shoot me an email, and I'm gonna put my email in right here, I can connect you with the right people to see if we can help you do that. There we go. My email is Eric. To make sure, yeah. So yeah, those are some great questions. And the question they're asking, James, man, your face is getting just big and small over and over. Man, we love you, James. So I'm just go back to the big screen, which I'll bet you're scaled out. That's weird. But your face is in there, and we'll just leave it at that. So yeah, I mean, when we wrestle, storage is a tough thing, and this is in topic here. Storage is a super tough thing to work with. Block storage, object storage, and how to and S3 is an amazing. If you think about what S3 did when it came out, it was an amazing thing. And then NFS and the ability to mount the same drive on multiple systems, and then of course EFS, which takes that again to a huge level. Storage is hard though, and that's why companies work hard to wrap their head around that with and Windows can struggle with NFS as well, and that's one of the things that in my previous day as a solutions architect that we struggled with also. So that's again, storage is hard. But it's interesting. I want to talk about this EFS pattern here. And James, do you have some more you're going to show as well? I don't want to talk too much here.
Yeah, I can talk you through the large file example just very quickly because it's pretty straightforward. I won't deploy it because it takes a few minutes, but I can walk you through the example. So the SAM template, this is in the third example in that repo, is the same design. It takes these parameters to configure the VPC and the EFS mount. And then we've got this function where I've put ffmpeg into a layer. And then what this function would do, if I just open up the process file app here, I've written this little function that essentially will run like a command line function for you. So it runs ffmpeg on this video file and outputs all of these frames from the video, 1 per second, back to the EFS storage location. So when you've got these kind of libraries where you just want to run something very quickly, this is a really useful node template you can use. It simply executes any command that you provide, and it interacts with the EFS mount very straightforwardly.
Wow. I posted a direct link to your repo as well.
Yeah.
So make sure that has that.
There's a good question there I'd love to tackle, actually.
Yeah.
There's about would this be a good way to auto-generate code libraries and includes? And yes, it would. That's a great question. So what you can do, if you think about how you include code in Lambda functions, you've got really 3 choices. You can zip up the file into your deployment zip file, or you can include a layer. You bundle up a layer and make that part of your deployment. And in both of those cases, you end up with this immutable version that sits there, and there's nothing that can do to change that version. Now with this, what you can do instead is have your builds of your libraries in your EFS space, and then if you're using something like Node, you would simply require files from that mount instead of from your local package. And what this means is that you can actually have dynamic builds. So if you have packages that maybe for your company, you have libraries of packages that change frequently, and you want to make sure that all of the Lambda functions are always using the latest version, that would be one way to enforce that kind of policy.
Yeah, and that brings an interesting pattern because, and talk about that mutable and immutable comparison, that brings an interesting pattern because, as Lambdas, we're used to, once that's out, that Lambda's immutable. The Lambda function's immutable in the data it's using and stuff until I update that, right? Now, it might read some immutable data and things like that, but this, the caveat is you got to be careful. Hey, I'm gonna upload, I'm gonna try to talk. I'm going to upload a new library to try it out. Well, the next time a Lambda function invokes, it's going to use that. So, that's the one caveat I'd wrap around that. But it's and the doors that are being opened on the ability to, hey, let's upload a new data set. Let's upload, let's add to this data set. So we're constantly, obviously, we want to use a database as well, but it depends on how you're using that static data. Is a great way to use it.
And there's a couple of other interesting cases around this. So, layers max out at 50 megabytes. And obviously, there's lots of packages that are frequently bigger than that. So this is a great alternative if you've got something big. Even things like Puppeteer, run at something like slightly over 50 megs. So you could deploy that and pull it in that way. But we see companies and customers who are using EC2 or containers to build applications, and by using EFS mounts, you can then use Lambda as a consuming source for those applications. It does open up all sorts of interesting build patterns that become available to you. And there's one question here about can you execute any FFmpeg CLI command from this wrapper? Yes, you can. So in here, anything that you can do in FFmpeg, you just simply provide this in this wrapper and it will run. Obviously, the caveat is that with Lambda, you have a 15-minute timeout limit. But if you've got a very long job, there are ways to break that up as well.
Yeah, and we've seen companies that take and break like videos apart. And hey, think about this, okay? So I drop a video in, and I break it into 30-second segments. I encode them all, transform them or whatever, and then I stitch them back together on the backside. And we see a lot of that kind of thing happening. So it makes a really fast way of making some changes.
Yeah. And, the examples 4 and 5 in this repo are worth looking at as well, just generally, because zipping and unzipping files are actually a very simple but powerful use case here. Because if you have a system where you've got thousands of small files, like a log system, for example, this makes it very simple to take all of those thousands of files and zip them up very simply. And the code is pretty straightforward. The stem template is very similar. And in this example, I'm just using an archive library in Node and then some default code here. But this can just take thousands of files and produce one zip file. And then in the 5th example, it does the reverse. Essentially, it takes one very large archive and breaks it out into thousands of other zip files. But it's really the EFS intermediary that makes that very easy to do.
I'm just posting the videos link.
Yeah.
All right. Well, we are running at time, and I messed it up. Hey, I'm gonna post it again here. Video. Okay. There it is. So we're at time, and we've actually had a lot of requests on Twitter and as well in here. This video, I will update it. It'll probably be up in the next hour or so on YouTube. James, what I think I'm gonna do is rather than pushing your stuff into my repo, we're just going to link straight to your repo. From the Sessions with Sam repo. I think that makes more sense because there's a lot of gold there. We were kind of talking about what should we pull over, but I think there's a lot of goodness there that can help folks out. And in that repo, do you have a list of your helper functions that you use?
Yes, each one of these is separated into its own directory. Okay. And then there's some commands down here that can help you find things like VPCs and subnets. But if you have any questions when you run this, I've put my contact information at the bottom of the repo, so feel free to reach out if you have any questions at all.
Okay. As always, you can reach out to me. Both James and mine's Twitter handles are in the links there. So glad to help. Next week, let me go to my end here. So I'm a horrible. I talk about what I'm going to do. So here's what you can do. So here's the repo that we'll link over to it as well. Next week I'm going to be talking about custom builds for Lambda functions. I don't know if you saw, but just this week we were able to do. We pushed out how to do a Swift Lambda behind HTTP API in SAM using SAM build. So I'm going to show how to do that next week. And then if you need more, check out our Serverless YouTube channel at slip.link/serverless. Thank you so much for joining us, everybody. Have a great time. Again, we'll see you next week, and keep building serverless for everyone. James, thanks for joining me. You are awesome, sir. Hang on a minute. I'm going to say that again. Come back to me. James, thanks for having me, or thanks for being with me. Your audio was cut when I was on that other scene. So, all right, we'll see y'all later. Have a good one.